This is our meetup. It's DIY-Robocars-NYC, and the links for all this stuff we will have. I have at a website which is byo-sdc.com. It's also in the email that they sent out to the group. So there's all kinds of notes and stuff talking about the things that I'm going to discuss tonight. So feel free to check that out. Anyway, so the goal of our group is we want to create something like the infamous homebrew computing club that existed back in the day with Steve Jobs and Wozniak and the people who were basically hacking and having fun and doing cool stuff, which led to a revolution in the industry. Except in this case, we're not talking about personal computers; we're talking about self-driving cars. The idea is to create an opportunity for amateurs, for hackers, for DIYers to participate in this technology in a way that's cheap and it's accessible, and hopefully it's a lot of fun. So the first big question is, why? What is the point of doing this kind of work on hobby scale vehicles when pretty much every major automaker out there now has an army of PhDs who are hammering away at this problem? So the first reason that I have is openness or accessibility. The architecture of a self-driving remote control car is not in principle all that different from that of a full-size vehicle. So working on a small-scale platform puts that architecture within reach of anybody who wants to learn. So online courses have given us an unprecedented access to classroom learning, and that's amazing. And from that democratization of knowledge, we're already seeing a huge surge in creativity, in collaboration, and experimentation, and innovation that comes from open source culture, right? What I hope is that we can extend that all the way down to the hardware. So there's no reason that you shouldn't be able to implement what you've learned in your class. If you've taken any of the self-driving car type classes, etc., that you should be able to implement what you learned in that class yesterday on your own self-driving car today, and then perhaps share what you've learned in the process in a blog post tomorrow, and spread the wealth of knowledge and make our industry better. The next reason is that real-world data beats simulation. If you guys have taken or are considering taking any of the available courses in self-driving car stuff from Udacity or Coursera or anywhere else, you'll have the opportunity to learn about and write algorithms for things like steering control and deep learning for behavioral cloning, obstacle detection, and path planning, and all that good stuff. But in most cases, you're going to run this code against canned data or on a simulator. But having access to a physical platform that allows you to move from code that works under idealized conditions to code that functions in the real world, with all its uncertainty and performance constraints and noise, is a very valuable thing. So if you see the image on the left, that's from Udacity's car driving simulator, which is pretty cool. We're able to actually emulate a human behavior driving, which was the inspiration for the stuff that Antonio did with his Android Robocar. But the image on the right there is actual camera footage coming from a real DIY Robocar that's running on a track out in San Francisco, and you can see some of the red and yellow colors there. That's actually the activation of the neural net as it's activating on the real data that's coming in. And in a lot of cases, you see that what we think is happening is not necessarily what's happening in real life. So it's cool to be able to run this stuff, your code like on a real platform.
Like, is that? I have a question. Is
Sure.
that just a loop, or?
This is just a loop.
Like, is there a longer video of this?
There is a longer video of that, and I'd be happy to find that and point you to it. But yeah, you can find this stuff on YouTube. And if you look on Twitter, DIY Robocars, they share all of their events that they have every month. So yeah, check it out. Anyway, yeah, so the image on the right is from the donkey car, which we're actually going to be discussing shortly. Don't get me wrong, I think simulations are very important for shortening the software development life cycle and for modeling situations that might never actually occur in real life, but they're just a starting point, and we need to be able to run our code in with real sensor inputs and be able to react in real time, and the sooner we can do that, the better. Cool. Another reason is the cost. On a cheap, small-scale platform, we have the freedom to explore and experiment in ways that researchers working on full-size cars can't necessarily do, at least without great risk and expense to their company. Which actually will tie into the next point, which is safety. Like I said, this is somewhat related to cost, because crashing a remote control car is not a catastrophic event in the same way that, say, crashing your Tesla is. And fear of catastrophic failure leads us to optimize for safety and preserving precious equipment without really pushing the boundaries of what our technology can actually do. So experimenting on these small-scale platforms allows us to remove that risk to some degree. I mean, you're risking a couple $100 instead of many thousands of dollars in potentially your own life. And that allows us to fail faster because the cost of failure is so much lower. And this, in turn, allows us to push the limits of what our software and our hardware can do. So this is a quote from Mario Andretti, who's a legendary race car driver, and I think it's appropriate here. As a software engineer myself, I know I have a lot of assumptions that I make when I write code, and it's important to put those assumptions to the test in real-world conditions and see where exactly they break down. So this allows us to write better, safer, and more robust software. So the question that you may be asking yourself at this point, after seeing all the stuff that you've seen tonight, is we've gotten already some presentations, but if you're not somebody who's very familiar with electronics, or you don't know anything about a soldering iron or whatever, how do I get started? Cool. So in addition to the stuff that you've already seen tonight with Android Robocars, I've got a couple of other projects that you might want to check out. These are guides that we can follow that have everything laid out, from the specific parts lists and how to assemble it all. And each of the projects that I'm about to show is well documented and should be possible to actually complete over a weekend. So the first one is the donkey car. And the donkey car, it was so named because, as they say on their website, donkeys are one of the earliest domesticated pack animals. They're safe for kids. They occasionally don't follow their master's commands, and the word donkey has a negative/ugly connotation, so expectations are super low. That said, people are doing really cool stuff with this platform. It's an ongoing project with an active community on Slack and Twitter where people are running their cars, they're training TensorFlow models, they're sharing their data with each other, and they're working on improving pretty much every aspect of the software. What you actually see here is the full package. That $200 thing covers buying an inexpensive remote control car chassis, getting the Raspberry Pi, a camera, and the roll cage here, which is just a 3D printed cage that they have available, and you can get it printed. If you have your own 3D printer, then it costs you virtually nothing, or you can get it printed over at Shapeways or on Thingiverse, etc. But work is now underway to make the, also this runs on Python. So if you're not Android developers, that might be news to your ears. But work is now underway to make Python software that runs the car more modular, so you can easily add in other kinds of functionality like Lidar, wheel odometry, and so on. So I think personally this is a fantastic place to start if you're interested in getting your feet wet, because the time to actually get something up and running is pretty short. So this is a video from one of the This is a video from one of the races in San Francisco. The little guy here on the left is the donkey car. Just to give you a sense of scale, this is a 1/16 scale remote control car, and this guy is a 1/10 scale, a little bit larger. So this gets pretty dramatic.
Get why it's called a donkey
Cool.
Are those the remote control?
So those are being totally driven autonomously. That's totally driven by software. So that was the DIY Robocar group in San Francisco. That is what we're trying to build a community of here in New York, to have those kind of races and just have some fun and do something cool. Anyway, on the higher, sort of more advanced end of the scale, we have the Formula 1/10 cars. This is a project that's, I'm trying to remember, I think it's developed over at Berkeley. At any rate, these are designed to use Lidar, the Nvidia Jetson TK1 SDK, which runs, I think you can get it with an educational discount around $200 or $300, and more retail it's like $500 or $600. It's a higher end board that's designed to run more intense, like TensorFlow type processes. It's got like 196 CUDA cores and all kinds of bells and whistles. And if you actually go to their website, they have a price list that totals over $3,000. However, that's all in with a whole bunch of optional equipment that you might not want to even start with in the first place, like infrared depth cameras and a $1,700 Lidar unit, which at this point you can now have for $300 or $400. So the price is coming down a lot. And there was that tiny Lidar project, which I've never even seen before, which is pretty amazing, $15. Pretty cool. Anyway, even if you're not interested in necessarily dropping a couple grand, I would highly recommend you check out their site if this is something that you're interested, generally speaking, because they have a very good set of instructions for building the hardware, the full system architecture, testing and tuning the algorithms, and working with ROS, Robot Operating System, to coordinate all the sensors, etc. I think that project's also in C++, so that's just let's see, and coming soon, Nvidia is actually getting into the game now, and they're going to be releasing their race car J. If you go to YouTube and you look up Nvidia race car or MIT race car, they've got a whole series of videos of building out this guy from scratch. But it looks like Nvidia is actually going to get into the market and start selling these things as a research platform. So as of right now, there's a form you can fill out to get notified when these are going to be available to buy. So the cost is yet unknown, but more than likely they're probably going to be at least a few $1,000s. At any rate, just the fact that they're promoting these means that people are recognizing the value of developing and running these small-scale platforms. So it's a good time to start doing this kind of stuff if you're interested in this as a career, for example. At any rate, join us on Saturday, August 19th. Our next meetup is going to be happening. And we're very grateful to, I'm very grateful to have the opportunity to talk to you guys and promote this. We're trying to build a community out here, and very excited about bringing this kind of a community over to New York City. It's already happening on the West Coast, and we'd like to see it happen on the East Coast too. And even if you're not necessarily interested in building the cars and you just want to watch these cars race, we'd love to have you. We'll have pizza and it'll be fun.
Where is it at? Where is it going to be at?
So the next meetup's going to be in Brooklyn. You can check out the meetup page. It's close to the 4th Avenue 9th Street stop on the F train, the R train.
Okay. Let's do it.
Cool. And one other thing, we need more space, especially if a lot of you come out to it. Right now, we're working out of a 1,500 square foot workshop, which sounds pretty big by New York standards, but really is pretty tight when you're trying to run a car around a track, and especially if you got very many people there. So if anybody is interested in sponsoring our event, or you know somebody who is a company, we're looking for an indoor space where we can race our cars on a monthly basis, ideally with a track that we could rely on staying the same shape from month to month. Because right now, what we have to do is pretty much tape out the track anew. So the data changes a little bit from track to track, which isn't the best if you're trying to train unreliable data, but maybe is good if you want your models to be more robust. At any rate, if you know anything about that, please come find me afterwards. And finally, if you'd like more information about any of the things that I talked about in these slides, or if I talked too fast, please go to byo-sdc.com, and thank you very much.